So we're on section 13.3. In this piece we're going to talk about is permutations. Permutations are an arrangement of objects where order is important. Previously we talked about combinations, and the difference between a combination and a permutation is that order matters for the permutation. With permutations, we care about the order of the elements, whereas with combinations we don't. Example is your locker combination. Your locker combination might be 5, 4, 3, 2. If you enter in 4, 3, 2, 5, your lock won't open, and because it's a different ordering. So technically it's really a locker permutation, not a combination, if you were referring to it in the mathematical terms. So the first thing we're going to do is we're going to look at listing all the possible permutations for these numbers right here. So I can write it as 1, 2, 3, or I can write it as 1, 3, 2, or I can write it as 2, 1, 3, or 2, 3, 1, or I can write it as 3, 1, 2, or 3, 2, 1. Notice I used a system. I started with the first digit and then just altered the next two just so I could keep track. Again, you're going to do that with these two. Take a second. Give it a shot. Pause your video. Did you get TV, TW, VW, VT, and WT and WV? Of course, your list doesn't have to be in the order of my list, but they all have to be there. Okay, so now we're looking at permutations. So to find a bunch of them, if I have a bunch of items and I don't want to have to write those sample spaces out like that, there's a formula. The formula looks like this. Basically, it says if I have n items and the order matters and I'm choosing them this at a time, I would take n factorial divided by n minus r factorial. Okay, again, n is the number of items that I have, and r is the number of items that I choose. So in this right here, I have 3 items, and I'm choosing 3 items. So that's what I did right here. I had 3 items, and I chose 3 items. I arranged them in all the different ways I could. My handy-dandy calculator has a nice button that shows me that, so I go to there. I have 3, and I hit the second button, and the NPR button, which is above the 9. And I hit the 3, and I hit equals. Whoops, that was incorrect. Let's try that again. I have 3, second, 9, 3 equals. 6 is my answer. So the answer is 6. But if I wanted to write it out, it would be 3 factorial over 3 minus 3 factorial. And remember that 3 factorial is 3 times 2 times 1, and 3 minus 3 is 0 factorial, which is 1. So then my answer is 6. Okay? So with that in mind, let's do this one right here. You take a stab at it. Did you get 6? This is related to this item up here. I have 3 things, and I'm taking them 2 at a time. I'm looking at the order that matters. So in this case, TV and BT are 2 different events, or 2 different outcomes. So again, if I wanted to write it out, it would be 3 factorial over 3 minus 2 factorial, which is 1. So my answer is going to be 6 again. All right. Find the number of unique permutations of the letters in each word. Okay, so I look at this right here, and I realize that I have 6 letters. So I have 6 things I'm taking. I'm doing a permutation of 6 things. However, 3 of the things are the same. Oh, let's back up. Let's do it with Debrits. How many different ways can I rearrange the letters in my last name? Well, that's 6, choose 6. And they're all unique letters. So if I was looking for how many different ways I could rearrange my letters in my last name, it would be 6, permutation of 6. And that's 720. Well, this is 6, choose 6. But notice that I have 3 of the letters that are the same. If the letters are the same, is it really going to matter if this is E1, E2, E3? Am I keeping track of that? I'm not. So once I figure out that this is 720, I have to divide out the 3, all the different ways I can arrange 3. Well, how do I arrange 3 things? Well, it's going to be divided by 3 factorial. Okay, because there's 3 E's. This is because there are 3 E's. And 3 factorial is 6, right? So 720 divided by 6 is 120. So there are 120 unique ways to rearrange these letters, dividing out the fact that I have 3 E's. Over here again, I have 1, 2, 3, 4, 5, 6, 7 letters. So I have 7, and I'm choosing 7 because I'm going to rearrange them, but I have 2 that are not unique, so I'm going to have to divide out the non-unique. Okay, so I'm going to do 7, choose 7, permutations. So I have 7, choose 7, and I get 5,040. But then I have to divide out 2 factorial. Because there are 2 R's, it's 2 factorial. This is 3 factorial. Okay? So when I do that, I'm going to divide out 2 R's. That's going to give me, it means I'm dividing it by 2, which gives me 2,520. Okay, you try. Do math. How many different ways can I rearrange the letters in math? Did you get 24? Then you got the basics. If not, make sure you ask me questions when we go over to get in class. Okay. So, Costello and Joe are planning trips to 3 countries this year. They have 7 countries they would like to visit. One trip will be 1 week long, another 2 days long, and another 2 weeks. And we have to figure out what are all their options. Okay, so here's the thing. I have to make adjustments for the fact that I have different time links I'm taking these trips. So that's where the order matters, right? Which one am I going to assign 1 week? Which one am I going to assign 2 days? Which one am I going to assign 3 days? So there's where the idea of order comes in. So I have 7 countries. Whoops. I have 7 countries. I'm doing a permutation because the order matters. And I get to only see 3. So I have 7 countries. I'm choosing 3 at a time. So all of the different ways I can do that is 7 permutation 3, which is 210. So there are 210 ways to do this one. Okay, on this one right here, there are 15 applications for 4 jobs. So again, the order is relevant here because which job are they getting, right? There are 4 jobs. So this is a 15 permutation because I have different things they're getting assigned to, and I get to choose 4. So 15, choose 4. I have 32,760 options for my outcomes when I hire 4 people out of 15. Okay, we're going to do some more in class. Let me know if you have any questions as they come up.